Welcome everyone to another episode of Wes Explains Best. Today we're doing a Khan Academy tutorial on fourth and fifth roots, and something I just noticed, if you look here after I hit this hide scratch pad, there's only 3 problems. That is new. I've only seen Khan Academies with 4 or 7, so 3 problems. Wow, kind of a benefit here, but let me go ahead and show you how we're going to do fourth and fifth roots. Now, if you have a calculator, you might be able to just use a calculator on this, but I'm going to show you how to do it without a calculator, and we're going to go ahead and get into it. Now, to simplify roots like this, what we're going to do is we are going to factor them first. So I'm going to factor this into its prime components. We need to think of our prime numbers here. 2, 3, 5, 7. I don't know why I'm putting commas after these. I am. I'm going to just stick to it. It's a sunk cost at this point. 17, etc. Okay, so we're going to think of any of these that are prime factors for this guy, and obviously we can do 5 here. So I'm going to divide by 5, and we have 625 divided by 5 is 125. So I'm going to divide by 5 again, and I get 25, and divide by 5 again. I'm going to get 5. Okay, now why did I do this? Well, first off, we're looking for the fourth root. So we're looking for what number times itself 4 times equals 625? Well, according to our factor tree, we could rewrite this problem as 5 times 5 times 5 times 5. Okay, by the very nature of the fourth root, what times itself 4 times equals 625, we already see that it's 5 that is multiplied by itself 4 times. So the fourth root, going backwards, is going to be 5. The trick is anytime we're doing these roots, we're looking for the number of factors multiplied this many times together, and that will be what leaves the radical. Okay, that will be our answer. So this is going to be 5 here, and we're on to the next one already. 243, okay, ooh, interesting. A way to see if it's divisible by 3, by the way, is we can add up the digits. So 3 plus 4 is 7, plus 2 is 9. So 9 is divisible by 3, so we know 243 is divisible by 3. And we're going to go ahead and factor that out. So we divide by 3, we get 81. We're going to divide by another prime number. 3, 27. 3, 9. 3, 3. Okay, now, we always need to look at the root there, and it says 5. What does that mean? That means we're going to be looking for anywhere we have 5 numbers that are the same. In this case, we have 5 3s. We could rewrite this if we wanted to as the fifth root of 3 times 3 times 3 times 3 times 3. Okay? What number times itself 5 times is equal to 243? Well, that is 3. We demonstrated there. 3 is our answer. 3. All right, next question, 1 over 32. Okay, we can separate this into 2 problems. Well, not 2 problems, but 2 roots. We can split it up so it's the fifth root of 1 over the fifth root of 32. Now, anytime we have a root with 1, it's just going to be 1 in the top. Okay, that's pretty simple. Now, but with 32, we need to go ahead and divide by prime numbers. And if it's even, always divide by 2. 2. Okay, so then we have 1, 2, 3, 4, 5 2s that we're going to circle together. And we could rewrite this if we wanted. Or we can just say, okay, if there's 5 2s I circled, I know a 2 is coming outside the radical, and that's going to be my answer. Okay, so fifth root of 1 is just 1. 1 times 1 times 1 times 1 times 1 equals 1. And then 2 times 2 times 2 times 2 times 2 equals 32. What times itself 5 times equals 32? That is 2. So the answer is 1 over 2, 1/2. And that's our answer, 1 over 2. And there's only 3 problems. How about that? Show summary. Hope you guys heard that sound too as you did this along with me. Thank you so much for watching and stopping by. Make sure to check out other videos on this channel. If you need something covered that I don't cover yet, or you need something a little bit something more explained, go ahead and leave a comment. Tell me what you need. I'm here for you. Thanks for watching. Catch you next time.